and Sai Ram to all. How are you all? I hope you all are fine. So, in our previous video, we have done atomic number, mass number, Bose model. Clear? So, in this video, we are going to study arrangement of electrons in the atoms. Before that, just revise what do you mean by atomic number and what do you mean by mass number. Basically, your atomic number is equal to number of protons. Is this clear? Number of protons is your atomic number. That means if in an atom there are 8 protons, that means the atomic number of that atom element will be 8. Is this clear? Now, next is mass number. What do you mean by mass number? Basically, your mass number is equal to number of proton plus number of neutron. Mass number is equal to number of proton plus number of neutron. Now, how you will relate what is the relationship between atomic number and mass number? Basically, your mass number is equal to atomic number plus number of neutron. Why? Tell me fast. Why your mass number is equal to atomic number plus number of neutron? See, as we all know that atomic number is equal to number of proton. So instead of writing number of proton, you can write here atomic number. Is this clear? So with this equation, or you can say with this expression, you can show the relationship between the atomic number and the mass number. Clear? So now let us start with the today's topic. Today's topic is arrangement of electrons in the atoms. Arrangement of electrons in the atom. As we all know that electrons are negatively charged. So, the cloud of negative charge outside the nucleus, we all know that electron revolves around the nucleus. So around the nucleus there are negative charge like this. Cloud of negative charge. The electron arrange according to their potential energy in a different energy level or shells. Now, there are different energy shells and they are denoted by 1, 2, 3, 4, 5, so on, or K, L, M, N, O, P. Clear? First energy shell is your K shell. First energy shell is your K shell. Second is L shell. Third is M shell. And fourth is N shell, so on. Clear? See, this is the energy level of electron shell in the atom. Here. Nucleus. After that, first energy cell, K, second L, third M, and fourth N. Is this clear? Clear? Now, in first energy cell, you can locate 2 electrons. In first energy cell, you can locate 2 electrons. In second, in K, you can locate 2 electrons. In second, you can locate 8 electrons. In third, you can locate 18 electrons. And in last, you can locate 32 electrons. So basically, this is the arrangement of electrons in the atoms. Clear? And the energy cell which is near to the nucleus, which is near to the nucleus having a minimum energy. Clear? As compared to farther one. Clear? Now just move to the next topic, and our next topic is electronic configuration of elements. Our next topic is electronic configuration of elements. So the arrangement of electrons. The arrangement of electrons in various cells or energy level of an atom. That means you are having number of electrons. So the arrangement of that electrons in different energy shells or energy level of the element is known as electronic configuration of the element. What do you mean by electronic configuration of the element? The arrangement of electron in various cells. The arrangement of electrons in various cells or energy levels of an atom of the element is known as electronic configuration of the element. Now, in order, if you want to write electronic configuration, in order to write electronic configuration of an element, we should know two things. Number one, the number of electrons in one atom of an element. The number of electrons in one atom of the element. That means कितने electrons present है उस element में. The second one, the maximum number of electron that can be accommodated in different shells of the atoms. This is clear. If you want to write down electronic configuration, what things you should know? Number one, the number of electrons in one of the atom of the element. Second, the maximum number of electrons. The maximum number of electrons that can be accommodated in different shells of the atoms. Now, see here. The maximum number of electrons which can be accommodated in any energy level of the atom is given by 2n square. Clear? So here your n is equal to energy level. So if your energy level is 1, so 2n square is equal to 2 into 1 ka square. 2 into 1 is equal to 2. So in first energy level you can locate 2 electrons. If we are talking about the second one, 2n square. So 2 into 2 ka square, because here n is your energy level and energy level is here is 2. So 2 into 2 ka square. So 2 into 2 ka square is 4. 4 2s are 8. So in second cell you can locate 8 electrons. Is this clear? So I am reading this once more. Listen carefully. The maximum number of electrons. The maximum number of electrons which can be accommodated in any energy level of the atom is given by 2n square. For first energy level, n is equal to 1. For first energy level, n is equal to 1. So the number of electrons in first energy level is equal to 2n square. Here your n is equal to 1. So 2 into 1 ka square is 1. So 2 into 1 is equal to 2. So in first energy cell you can locate 2 electrons. And the second point is, the outermost cell of an atom cannot accommodate more than 8 electrons. The outermost cell of the atom cannot accommodate more than 8 electrons. Even it has capacity to accommodate more electrons. That means I told you that 2n square. Clear? In third is 3 square. 2 into 9, 18. That means in third energy cell we can locate 18 electron. But you can't locate 18. You can only accommodate 8 because of the octet rule. Is this clear? So That means in first cell you can locate 2, after that you can locate 8, 8, 8, 8, 8, 8. Even they have tendency to accommodate more electrons. Is this clear? Now I am reading once more this slide. Listen carefully. Electronic configuration of elements. The arrangement of electrons in various cells or energy levels of an atom of the element is known as electronic configuration of the element. In order to write down the electronic configuration of an element, we should know two things. Number one, the number of electrons in one of the element. The maximum number of electrons that can be accommodated in different cells of the atoms. Clear? And the maximum number of electrons which can be accommodated in any energy level of the atom is given by 2n square. The outermost cell of the atom cannot accommodate more than 8 electrons even if it has capacity to accommodate more electrons. Clear? Now, the third point is electrons in an atom do not occupy a new shell unless all the inner cells are completely filled with electrons. That means if you are locating electrons, they cannot accommodate like anything. First you have to fill the first energy shell, that means 2. Then you have to locate the second, that means you have to complete the full 8, then next 8, then next 8. Is this clear? See this example. Write the electronic configuration of element X whose atomic number is 12. Here atomic number is 12. So in first energy shells we can locate how many electrons? We can locate 2 electrons. So atomic number is 12. Out of these 12 we already locate 2 electrons. So how many is remaining? 10 is remaining. So in second shells we can locate how many? 8 electrons. So 8. So 2 plus 8 is 10. Out of 12 we'll already locate how many electrons? 10 electrons. Now how many is remaining? 2. In last 2. Is this clear? Like this you can write the electronic configuration. Now here, write the distribution of electrons in a carbon atom. Atomic number is 6. Atomic number of carbon is 6. So in first energy cells, how many electrons we can locate? We can locate 2 electrons. Out of 6 we have already located 2 electrons. How many is remaining? 6 minus 2, 4 is remaining. So in next cell how many electrons will come? Only 4 electrons will come. 4 plus 2 is 6. Is this clear? Write the electronic configuration of sodium. Atomic number is, you have to write these atomic number. Sometimes in exam atomic number is given to you and sometimes it is not given to you. So atomic number is 11. Clear? So in first energy cells, how many electrons we can locate? We can locate 2 electrons. Clear? Out of 11 we have already located 2 electrons. Out of 11 we have already located 2 electrons. How many is remaining? 9 is remaining. And in second energy cells how many electrons will come? 8 electron will come. So 8 plus 2 is 10. 10 is already located. How many is remaining now? 1. So in last energy cell 1. So this is the electronic configuration of sodium. What would be electronic configuration of a positively charged sodium ion and what would be the atomic number? See, Na plus, if it having a plus charge, if it is having a plus charge or positively charged, that means it donate one electron. So we know that atomic number of sodium is 11 and electronic configuration was 281. Now if they are having plus charge, that means it has already denoted one electron. So for Na plus, the electronic configuration would be 2 and 8 and its atomic number would be same. Atomic number will not be changed. See, the atomic number of an element is equal to the number of protons in an atom. We know that, na? Atomic number is equal to number of protons. Now Na plus donate electron. It has not donated proton. It has only donated electron. So atomic number would be same. Clear? Explain why sodium ion Na plus has completely filled Kn shell. Maximum, why? Because maximum capacity of K shell is 2. So 2 electrons are there, and L 8. So 8 electrons are there. Clear? So that's why they are completely filled up. Now if both K and L shells of an atom are full, what is the total number of element in that atom? Electrons, sorry. See, in first, if they are full, that means in first 2 electrons are there, and in second 8 electrons are there. If they are completely filled, that means 2 and 8. So 2 plus 8 is 10. So the atomic number would be 10. Sorry, number of electron will be 10. Is this clear? Now this is a chart. Here we electronic configuration of first 20 elements. See, we know that the hydrogen atomic number is 1. So electronic configuration will be 1 only. Helium 2. So 1 and helium is 2. So 2. Lithium is 3. So in first 2, then 1. Beryllium 4, so 2 and 2, because in first electron you can locate 2 and in second you can locate 8, but the atomic number of beryllium is 4. So out of 4 you have already located 2. So how many is remaining? 2 is remaining. So this 2 will come here. Clear? Now boron atomic number is 5, and in first cells you can locate only 2 electrons. So out of 5 you have already located 2. So how many is remaining? 3 is remaining. In the second cell you can locate 8 electrons, but here only you can remaining electron is 3. So electronic configuration is 2 and 3. Carbon 6. In first electron, how many electrons you can locate? You can locate 2 electrons. So out of 6 you already locate 2 electrons. Now how many is remaining? 4 is remaining. Clear? Chlorine, chalo, take the example of chlorine. Atomic number is 17. Now in first cell you can locate how many electrons? 2 electrons. So out of 17, 2 are there. How many is remaining? 15 is remaining. Now in second, how many can you locate? You can locate 8 electrons. Clear? 8 plus 2 is 10. That means out of 17 you have already located 10 electrons. Out of 17 you have already located 10 electrons. Now how many is remaining? 7 is remaining. 7 will come here. 2, 8 and 7. Clear? Calcium atomic number is 20. Calcium atomic number is 20. Now in first energy shells you can locate how many electrons? You can locate 2 electrons. So out of 20 you have already located 2 electrons. So 20 minus 2 is 18 are remaining. In second you can locate how many electrons? 8 electrons. So 2 plus 8 is 10. Now how many is remaining? 10 is remaining. Now in next electron you can look at 8 electrons. So 2 plus 8 is 10. 10 plus 8 is 18. How many is remaining now? 2 is remaining. Then again 2 will come. So 2, 8, 8, 2. So this is the electronic configuration of calcium. I think it is clear to you how to write electronic configuration of an element. Clear? Now, next topic is valence electrons. Next topic is valence electrons. See, as we all know that the outermost electron shell of an atom is known as valence shell, because जो outermost है उसी में वो इलेक्ट्रॉन लेगा या उसी का इलेक्ट्रॉन वो देगा. So those cells in which electrons can donate or electrons can gain is known as your valence cell. Valence electron, those cell is known as your valence cells. Clear? Now what do you mean by valence electrons? The electrons present in the outermost cell of an atom. The electron present in the outermost cell of an atom are known as valence electrons. Are known as valence electrons or valency of electrons, because they decide the valency of the atom, because they decide, okay, what they want to do, either they gain or lose. Those electrons of an atom which take part in a chemical reaction is known as a valence electron. Valence electron also take part in a chemical reaction. Valence cell take part in a chemical reaction. Valence electrons are located in the outermost cell. Valence electrons are located in the outermost cell. Clear? Now our next topic is inertness of noble gases. Basically, the outermost electron of an atom take part in a chemical reaction. Since and noble gas, inert gas are basically those gas in which last cell, outermost cells are completely filled. Clear? Your last outermost cell is completely filled. If they are completely filled, that means they are chemically unreactive. Why? Because all the noble gas have completely filled outermost cells. That means they will not either they will not lose an electron और they will neither lose the electron nor gain the electron. वो ना ही lose करेगा ना ही gain करेगा. जब वो ना ही lose करेगा ना ही gain करेगा, that means the inert gases are unreactive. Is this clear? And the atoms having 8 electrons in their outermost cell are very stable and hence chemically unreactive. अगर आपका outermost cell is completely filled, that means 8 electrons are there. वो आराम से स्टेबल रहेगा एंड वो अनरिएक्टिव रहेगा. दे विल नॉट पार्ट ऑफ अ केमिकल रिएक्शन. Is this clear? What do you mean by what are the noble gases? Noble gases are those gases in which the outermost cells are completely filled. That means in the outermost cells there are 8 electrons. Clear? Helium, for example, helium. Atomic number of helium is 2. Clear? So how you will write the electronic configuration? It is 2. And in first cell how many electrons can come? Only 2. तो क्या होगा, ये ना ही ये गेन करेगा ना ही ये लूज करेगा, तो ये क्या आपका अनरिएक्टिव है. इट इज अनरिएक्टिव. इज दिस क्लियर? So it is a noble gas. Clear? Now take another example. Neon. Atomic number of neon is 10. Now see, 10. In first energy cell, you can look at how many electrons. You can look at 2 electrons. Out of 10, you have already located 2 electrons. How many is remaining now? Now 8 is remaining. So 8. In first cell, maximum number of electrons can be accommodated is 2. And in second cell, it is 8. So it is completely filled. Clear? Now ये ना ही लूज करेगा ना ही गेन करेगा. So that's why it is unreactive and it is a noble gas. Argon, 18. Atomic number of argon is 18. In first cell you can locate 2 electrons. In second cell you can locate 8 electrons. So 2 plus 8 is 10. Out of 18 you have already located how many electrons? 10 electrons. Now how many is remaining? Tell me fast. 8 is remaining. So in the last cell, how the maximum number of electrons you can accommodate is 8. So it is completely filled. So it is stable and it is unreactive because it will neither gain the electron nor lose the electron. That's why it is a chemical. That's why it is unreactive and stable. Clear? I think with this, inert gases or noble gases is also clear to you. So for today it is enough. We will finish the lecture. In next video we will go ahead with the further topics. Thank you and Sai Ram.